you have to be in standard form, and your equation has to be equal to 0. If it's not equal to 0, you need to move it over, right? So here we go. We're going to try it. I want to show you that it works by factoring or by the quadratic formula. This one is factorable. Everyone see where we are? Oh, real quick before I forget, I'm going to change my, let's factor that first one. What method should I use? Yeah, FOIL or the diamond method in this case, right? Because I've got 3 terms and I can write set up 2 terms, put an x in each. Minus here plus there. Listen when I preach. Remember? I'm going to play that one again, I think. No, it's okay. So I'm looking for the factors of 15 that add up to -8, -5, and -3. So x minus 5, x minus 3 are my factors. It is equal to 0. So here are my 2 solutions for x. +5 or +3. Those are my x-intercepts. So if I looked at the graph of this using a graphing calculator, that is where I'll take the risk. Let's see, x squared minus 8x. Oh, I didn't do a warm-up today of trying to find x-intercepts. Okay, I just wanted to prove to you that these are in fact hitting at 3 and 5, right? There's my quadratic, it hit at 3 and 5. All right, let's use the quadratic formula to just show you that it'll work out the same answers. So I like to label what A, B, and C are before I start. What is A in this problem? 1. B is -8, and C is 15. And I'm just noticing that, yes, this is equal to 0. So I'm ready to use the quadratic formula. So what's the opposite of B? +8, right? So the opposite of B is +8 plus or minus the square root of, what is B squared? So -8 times -8. So B squared minus 4AC all over 2A, right? So what is A? We said A was 1. And what is C? C is 15. So I have the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. I feel like you'll start to sing it in your head even if it's not out loud, and it helps you get through the problem and make sure that you're not missing one of those numbers from your formula. Yep, so then let's simplify this. So 8 plus or minus, what number is under the square root? If you don't know in your head, what you can do is type 64 minus 4 times 1 times 15 on your calculator. Under the square root, 64 minus 60 is just number 4. And I'm dividing by 2 times 1 is 2. So then, what is the square root of 4? So I have 8 plus 2 over 2, and I have 8 minus 2 over 2. Right? I should write equals, I guess. So I just wrote it as 2 separate fractions, one with the plus sign and one with the minus sign. So now I can get my final 2 answers. See how this is 10 divided by 2, which is 5, and this is 6 divided by 2, which is 3. Magic. Does that not seem like magic? I think that is cool. That formula can figure out those x-intercepts the same way factoring can. Does anyone else? Isn't that cool? I could never have come up with a proof like that, but that is like, wow, how does all this end up figuring that out? So people that get stuck on the unit test, oh no, I don't know how to factor this. You could use the quadratic formula and factor it backwards, right? Now that I know that 5 and 3 are my solution, ooh, I know my factors should have been x minus 5 and x minus 3. So you can use the quadratic formula to help yourself factor if you're really stuck on factoring. What was your question, William? You sure? Okay. Were you going to critique my singing? Oh, good. Alrighty, so here's another one. Solve by quadratic formula. We really want to use it when it's not factorable, right? Are there any factors of -3 that add up to -7? No. So this is a prime. So I need to use the quadratic formula to figure it out. So let's set up our A, B, and C values. See on this example, and then you're gonna, so -1 for A, -7 and +3. I probably should have double checked that it was equal to 0 before I wrote them down, but thankfully it was. So I'm gonna sing the tune as I put it in the formula. The opposite of B is what? Plus or minus the square root of B squared. +49. And if you are kind of typing this on a calculator, if you type -7 squared and just say -49, you know that you have to type -7 parentheses squared is +49. So this should be positive every single time. -4AC. So what is my A value? -1. And what is my C value? 3. And then all over 2A. So I put 2 times -1 in the bottom, and now I have the job of kind of simplifying all that stuff. Let's see, what is negative times a negative? A positive. So this is going to be +12, right? Because it's 4 times 3 is 12. So let's see, what is 49 plus 12? 50, is that 61? 49 plus 12 is 61. Is that a reducible radical? Nope, 61. I think it's prime. So I would have 7 plus or minus the square root of 61 all over -2. I could leave my answer in reduced radical form, but I can't really figure out the x-intercepts, right? I don't know where I am. So if you had to type this in and find the decimal answer, you would want to type in 7 plus the square root of 61 divided by 2, 7 minus the square root of 61 divided by 2. Let's find the decimal answers as well, because on a test, you might have multiple choice, and I might not give the answer in that format. I might give the decimal answer. This is tricky to plug into a calculator. You either need to put parentheses or you need to add, hit enter, and then divide by -2. So I'd like to see if you can calculate what the decimal answers are, because this is a skill, how to find them on a calculator by typing them in. So this calculator needs to get charged up. Who needs a calculator at their desk? Charge them. See how long it takes to that. Yeah, it's like pull out the calculators. Which one's oh, just came out of the charger, right? Here you go. We have this dinosaur. Oh, look. Here you go. Oh, dinosaur for you. You need one too? Who else? Okay. The dinosaur is the kind I had TI-83 in high school. That makes me old. Who else needs one? Or is this you're not using this, right? Who else needs one? I want you to type in the square root on your calculator. Here you go. The square root button, and then tell me the 2 decimal answers, so that if you had to, oh, I have 2 calculators hidden in this bag. Who else needs one? You all have one? Who did I give you almost dead? Charge that one up. If you're playing the game, let's see, 7 plus the square root of 61 divided by -2. And what's my other answer? 7 minus the square root of 61 divided by -2. 7 plus and 7 minus. You have 2 solutions at the end. Yeah, so that one out, right? Yeah, you got it. How did you get, oh, you use the fraction button. Both of them are divided by -2. Oh, you know what? So you're going to have to do your 7 what I got for that. And negative 0.41 is what I got for that. And that was me typing them in. So negative 7.41 and positive 0.41. But if you didn't get it, I should look at your calculator and see what you did wrong. You get the second key, and then it's over right there. See that sort of symbol? What is it? Negative? Oh. What? What? Oh, yeah, sorry. I wrote a negative in the circle, and I shouldn't have, right? This one should be a positive 0.41. Sorry, thank you. Did you guys figure it out? Oh, and then it doesn't like that. Yeah, because it doesn't know subtraction. Okay, so you're going to have a chance to practice a few of those. Oh, error? So it doesn't like that you divided by negative 2 under the square root because it made it a negative. So you need to go back up here, delete, 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 delete. You don't need this right now. Okay. So now you have 7 plus the square root of 61, close parentheses. Now divide by negative 2. So you got to arrow over to get out of there. Okay, thanks. I'm going to leave this right here. Okay. The discriminant, I think I'm going to leave till tomorrow because that way we can talk about the discriminant and talk about the quadratic formula again. I just want to take a look at page 30. See. Page 308. So do you see how 1 through 4 say how many solutions exist using the discriminant? I'm going to skip those for a second. Let's solve 5 and 6 using the quadratic formula. Thank you so much. The one is not going to come out with a solution, so that'll be good. And then actually on the homework, oh, okay. We might have to go back and do the discriminant in a minute. I want to show you 5 and 6. Yep. Well, parentheses is not a problem. You just have to get out of the square root and then close that other parenthesis and then divide by 2. So it's okay to have a parenthesis under the square root, but you got to arrow out to get out of it. So how is this set up a little bit differently? I don't see an equals 0, but it says find the x-intercepts. So I know that it's equal to 0 if I'm finding the x-intercepts. So let's set this one up. What is A, what is B, and what is C? So A is 2, B is 3, and C is -7. See if you can write out the quadratic formula by yourself this time. So we put it in the right order. So the opposite of B plus or minus the square root, B squared minus 4 times A times C all over 2A. How did you do at least setting up where the numbers go? Okay. Okay, see if you can simplify it. You can leave it in reduced radical form. Or as a decimal. Because this is going to be positive, right? 4 times or -4 times -7. So, but if you can't do the math, type it into a calculator. 9 minus 4 times 2 times -7 gives me 65. So you'd have -3 plus or minus The square root of 65 divided by 4. I don't think 65 has a perfect square, right? No 9, no 25. So I can leave my final answer like that, or I can put it into decimals. But to me, that's the exact answer right there. Well, 2 times 2 was 4. Yeah, I did. 9 minus 4 times 2 times -7. I was just saying that negative will make this a positive number. 9 plus positive 56. All right, number 6. I think this is the one that we're going to have a problem with. Because I think I was trying to find one that would have no solution. I think this one has no solution. Not positive yet, though, I think. A is 1, B is -3, and C is 10. See if you can put it into the square root. Maybe it does have a solution. I can't remember. I thought I looked at it quick and this doesn't have a solution. You can, yeah, actually find the square root. I think the square root has a problem. Yeah, good. So the opposite of B, plus or minus the square root, B squared minus 4 times A times C, all over 2A. I'm taking 9 and I'm subtracting 40. Can't do that, right? Can't take the square root of -36. Because this would be plus or minus the square root of negative, oh no, not -36, -1. Is that what it would be? All over 2? No solution. Yeah, well, you could leave it as the square root of 31i. But we're just saying no solution. We're looking for x-intercepts. There's no x-intercepts. Okay. I feel like I lied. I have to go back and show you the discriminant. Pretty quick. That way people who want to get the homework done tonight can, and then we're going to break into our groups to try to finish the that spirit socks problem. Well, what if you're not here tomorrow? Then you can't do it for Monday. This way no one has an excuse. Well, Jake, if you're not going to do it tonight, are you saying you're going to do it for Monday? Discriminant. It's not discriminate. It's the discriminant. Okay, the discriminant is b squared minus 4ac. Where do you see b squared minus 4ac in the formula? Under the radical. So we're back to resource page 10. Shouldn't have flipped back and forth. Oh, 11? 311, the discriminant. B squared minus 4ac lives under the radical. It's going to tell us some things about our graph. And so here, I just have 3 examples to show you the 3 possible outcomes of a quadratic. So when we try to find the discriminant, so on each of these examples, we're going to find b squared minus 4ac. What is b squared in this problem? So -6 squared is 36 minus 4 times a is 1 times c is 9. Well, that's just 36 minus 36, isn't it? Because 4 times 9 is 36. So that is equal to 0. So I said, can you take the square root of 0? Yes. Yes. The square root of 0 is equal to 0. So then what I did, if you kind of look down this column, this is equation A, and this is the same graph, graph A. How many x-intercepts are on this graph? There is only one x-intercept. The square root of 0 is just 0. Is plus or minus 0 the same thing? So when you do the equation, plus or minus 0 still only gives you the same outcome. So there's only one x-intercept, one x intercept, right here. So when the discriminant is 0, you'll only have one x-intercept on the graph. So see at the very bottom of the page, if the discriminant is 0, then there is one solution, one x-intercept. All right, something else is going to happen on B. What is B squared in this example? There is 0 B value, right? There's 0 x's. So B squared minus 4 times A times C comes out to what number? What's negative 4 times 1 times 2? Negative 8. Can you take the square root of a negative number? No. So how many solutions will be on your graph? We already know this. There will be 0 x-intercepts, 0 x-intercepts. So this equation has been transformed of 2 units, so it will have 0 x-intercepts. Does that make sense? So when your discriminant at the bottom here comes out negative, there will be 0 solutions, 0 x-intercepts. So what's the only other thing that could happen? I got something to come out as 0, something to come out as negative. This one's going to come out as positive. B squared is 16, because 4 times 4 is 16. Minus 4 times A is 1, and times C is 3. Yep, so what is 16 minus 4 times 3? So 16 minus 12 is 4. Can you take the square root of a positive number? Yes, you can. And if I get the square root of 4 here, that gives me positive 2 or negative 2. So it changes the outcome, right? So there's 2 possible x-intercepts for this one. And you can kind of see this is this guy's graph. Yep, I had 2 x-intercepts. So there will be 2 solutions when your discriminant is positive. So I go down here, there will be 2 solutions, 2 x-intercepts. So I'm not going to do the examples right now. You might have time to do some in your group, but if it asks you for the discriminant, please don't do the entire quadratic formula. You're doing a lot more work for yourself. All you have to do is figure out this number, b squared minus 4ac, and write a conclusion. There will be 2 solutions, or there will be no solution. If it's just a discriminant, that's all you have to do. If it says to find the solution, then you have to do the whole problem. I'm going to put this equation on your test. I'm not going to tell you that this is the discriminant because it's part of the equation. I'm not going to tell you that this is the x value of your vertex. It's kind of part of the equation. So if you have this equation on your test, you actually have 3 separate pieces of information. You have the quadratic formula, you have the discriminant, and you have the equation to get your vertex in standard form. So it's kind of a 3-in-1. And I'm hoping that by singing it, by knowing it, you could